Okay, so like I said, by the Heine-Borel theorem, K is bounded and also closed, right? So by the Bolzano thing, there is a sequence, a subsequence, X and L, that converges. Convergent subsequence, but we don't know where it converges to. And now, K is also closed by, again, the Heine-Borel theorem. And that means that this convergent subsequence is not just convergent, but the limit must lie inside K, because that's what we characterize closed sets by, if you look at the last week's notes when we talked about sequences. Right? So this was the forward direction, and I suggested how to do this other direction. So this is this week's, that's not how you spell quiz, weekly quiz. Right? So suppose that every sequence of K, of elements of K, contains a convergent. And convergent, I should always specify inside K, right? Because it could converge outside K, but that's not what I care about. Inside K subsequence. So that's what we are assuming. And what do we want to prove? We want to prove that K is compact. So by, this is the, like I said, if I didn't give you this outline, this would probably not be that easy to show, right? By Heine-Borel, we need to show two things, and these are two separate things, right? We need to show first, K is closed, and second, K is bounded. Because if we show those two things, the Heine-Borel theorem, which is actually the hard part of the Heine-Borel theorem, tells us that this is closed, compact. So who can tell me, and we have the remaining, what is it, 25 minutes of the lecture to answer this question. So who can tell me, how do you show that K is closed, and how do you show that K is bounded? And feel free to just unmute yourself, tell me any ideas that you have. If you feel completely lost and you have no idea how to answer any of these questions, then also please let me know. Many people write privately in the chat, so you can also just do that. Let me pause the recording and I'll unpause it and maybe give part of the answer.